Hello, welcome to the virtual open house for the Masters of Urban Spatial Analytics here at the Weitzman School at the University of Pennsylvania. My name is Ken Steiff. I am the program director of the Musa program and a professor in the Musa and city planning programs. I'm excited, obviously, for you to have been admitted to the Musa program. I hope to work with you all in the fall. In between now and then, I'm going to provide you here with some information about the Musa program that I hope you will find useful. You should also mark on your calendar Tuesday, April 7th. You've all received emails about a live open house where you'll have a chance to talk to some current students, see some current projects, ask questions of me. If you are joining us because you've been admitted to a different Weitzman program and you want to learn more about the Musa program, please shoot me an email. My email is at the bottom of this slide, and you can join on the live version of this on April 7th, or we can exchange emails. But let's jump into it. So here's what I would like to do in our few minutes together today. I'd like to tell you the motivation for the Musa program. I'd like to tell you about the courses and the requirements of the program. I will show you a bit about the Musa practicum, a capstone option that you all will have the option of taking. And I will show you about, throughout the course of the slides I'm going to show you, I will tell you about how applied this program is and how the goal is really to fill your head with a tremendous amount of new skills in a relatively short amount of time to get you up and into the labor market directly after the program finishes. And I'll finish by showing or talking a bit about the community that we try to foster in the Musa program. So the Musa program exists at the intersection of spatial data science and public policy. And specifically, I think what makes us really successful and unique is the idea that we are successfully able to teach data science to social scientists. Most of you fall under that category. You come to us with social science backgrounds relative to engineering or computer science backgrounds. I'll talk a lot about this idea of data science in a moment, and it's clearly a buzzword, but it means something very specific to us in the Musa program. So here are some ways that I think help motivate what the Musa program is. If you go and take a class on data science or machine learning or something similar in an engineering or computer science school, they will really emphasize the algorithm, what's going on under the hood. And while that's important to us, that's not the approach that we take. We take an approach that starts by motivating particular use cases and problems. I want to get you really interested in questions around transportation, in questions around policing, in questions around environment. And once I can sell you on how exciting it might be to solve that problem, then I can introduce an algorithm or a methodology to use some data to help you do that. So we are very much focused on use cases, not on methods primarily. And we're really successful by fostering a community of like-minded nerds. And that's not only our students, which are obviously the most important component of the Musa program, but it's also in the professors. So pretty much every professor in the Musa program has a day job, which is to say that we're not academic scholars, myself included. We work with data and we work to convert data into some sort of business intelligence or public policy intelligence. And we do this every day. We sort of live and breathe this stuff. We are inspired by it. We're super excited about it. And I think most of that excitement comes through when you take our classes. And it tries to, I think it fosters a level of enthusiasm in the Musa program that's pretty unique. So we use data, but we don't use it to do the kinds of traditional academic research that informs most public policy or social science programs. While that kind of research is important, and we do some of that, our emphasis is on this idea of data science. The way we think about that is really high resolution, day-to-day operational decision making. And for reasons you will learn, here today for a few minutes, but particularly in the Musa program, this idea about converting data into something that's an actionable decision-making analytic, there's tremendous value. And obviously that value is evident in the private sector, and we really work to move that value into the public sector as well. And we do this armed primarily with free and open source technology. We still teach some ArcGIS, because there are some sectors of the labor market that still rely on it. But we believe in open source technology primarily. And we believe in it because there are communities of interesting individuals who build new technology, who showcase tutorials and new use cases, who compile data sets and share it free and open with the rest of us. And we think that kind of community is a much better catalyst for innovation than the traditional off-the-shelf subscriber software model. We also do it because many of the things that we do in the Musa program, we want to be reproducible. You will see in the Musa practicum, we want to create a product once, and then we want to have another city come along that has the same problem, borrow our code, hack it together, and do something cool with it. And you'll see some examples in a few minutes. Another thing that makes this really unique is our emphasis on place and space. Many of you come to us with backgrounds in spatial analysis and in geography. You understand why the spatial component is important. That's becoming increasingly important, obviously in the public sector, but in the private sector as well, with companies like Airbnb and Zillow and Uber. And the people who go through the Musa program understand how to take data that has this unique spatial dimension and convert it into a decision-making analytic that answers a where question. Where should I send an Uber car? Where should I invest this subsidy? Where should I inspect for fire risk? Where questions. And finally, because many of you come to us with these diverse interdisciplinary social science backgrounds, we show you how to use the creativity that you have to solve complex problems. Problems that you might have thought were really only in the purview of engineering and computer science students. We teach you how to use the skills you have to solve those very same problems. And I think we do a pretty good job of doing it. And I hope you will see in this few slides ahead some evidence of that. All right, so the requirements of the Musa program are pretty simple. It is over 2 semesters, fall and spring. You have to start in the fall because, as you'll see, the process is linear from fall to spring. There are 9 classes you have to take. You can, of course, take 10. You could take 5 in the fall and 5 in the spring. That's a very demanding schedule. We can talk more about the option for doing that. But the way it breaks down is as follows. You take 5 data-driven courses. I'll explain those to you in a moment. You take 2 urban content courses where the emphasis is on domain expertise. I will show you those examples in a moment as well. 1 elective and 1 capstone, and I will spend some time on that also. All right, on to courses. So these are the Musa courses as they currently exist. I'll mention a couple things about each one of them. Spatial statistics and data analytics is really an introduction to statistics and spatial statistics. Again, many of you have some experience in this, but this is really designed to explain them, teach them at a higher level using R. This class is taught in R. The next class, geospatial software design, really runs the gamut, but you could do everything from building custom geospatial apps in Python all the way through using Google Earth engine to analyze satellite imagery. Public policy analytics is my class in the fall. It is taught in R. It is every week is applied data science use case in the public policy realm, everything from criminology, transportation, environment, housing. We cover algorithmic fairness. We cover some legal issues and data privacy. But it's very, very applied. You will have an introduction to machine learning both in that class and in the class that follows, geospatial data science in Python, which is about giving you data science skills in Python. Now you will notice that both public policy analytics, geospatial data science, and the class that follows have triangles, and those colors correspond to to threads, to classes that begin in the fall and have a second class in the spring that it prepares you for. So my class, Public Policy Analytics, prepares you for the Musa practicum. Geospatial Data Science in Python prepares you for remote sensing, which I'll talk about in a moment. And finally, the last class in the fall, it's in italics because we hope to add it this upcoming fall, called Geospatial Cloud Computing and Visualization, is really, again, it would be a new class. It's a class that teaches APIs, that teaches PostGIS, that teaches how to wrangle and store the troves of data that we now access on the internet, and some introduction to visualization that's taught with a number of different technologies. And those classes really prepare you for the spring, where there are classes. The first class, Modeling Geographic Space, is taught by Professor Dana Tomlin, who invented most of the raster-based spatial analysis that we do now. It's an incredibly important class for learning how to think spatially about problems. Land use and environmental modeling, a class that I teach, which is applied analytics in both the land use and environmental planning realms. JavaScript programming for planning, which is really a class in web-based mapping applications. That would be the second class after geospatial cloud computing. And finally, remote sensing, which is a pretty exciting class that we put in this year, that's really responding to a huge explosion in the geospatial industry of using satellite imagery. As companies like Planet Labs are imaging the entire planet once a day, we want to teach our students how to use that data. So whether it's counting the number of cars in a parking lot, the number of boats out in the sea, following the health of coral reef systems every day, these use cases that used to be impossible even a couple years ago are now possible. This class is it's a very technical and applied class taught in Python, and as far as I can tell, we are the only planning program that has a class like this focused on traditional remote sensing as well as deep learning, the new and advanced style of remote sensing. And finally, two capstone options. So the first one is an independent study where you can pursue a topic of your choosing. And the second is the Musa practicum, applied data science projects for actual governments. I'll talk more about that in a few moments. All right, so as part of the requirements, there are two urban content classes you have to take that are related to one another. And you can take them from across the university. And here are some examples of schools and concentrations where our students tend to go. I would say about 80% of the students stay in planning and focus on those first 5 domains that you see there. But students go, as I said, across the university. I am open for you to take classes wherever you would like, so long as you come and talk to me about what you're interested in. As long as your two classes are related. We'll talk a lot more when you're choosing classes about the urban content requirement in the summer. All right, on to the Musa practicum, which I am incredibly excited about. The Musa practicum began, this is year 3 that we're working on this semester. It began in 2018. The way it works is that we spend the fall developing applied data science projects with cities, governments around the country, and we sort of tee them up for you to begin in January. And you can see these are the use cases in 2018. Use cases focused around public health, such as this one predicting household lead risk in Minneapolis, this one predicting opiate overdoses in Providence. Do a lot of transportation work, a lot of housing community development work. This is a project predicting foreclosures in Philadelphia. These are the projects from last year. Again, more public health, more housing, predicting illegal rentals, more transportation. This project right here, predicting congestion in Louisville. And this year, those topics very much carry over. We have a team trying to predict scooter demand. We have teams working in child welfare, teams working in transportation and fleet management, more in the public health and public safety realms. And what really makes this, besides obviously creating a really hyper applied use case for an actual city, I think there are a couple things that makes this learning experience unique. And it starts with the fact that one of the deliverables for this project is this markdown. And this markdown is really designed not for a engineer, but again, for a non-technical policymaker. It is written in an accessible way. and it is driven mostly by data visualizations. You will see something that's really important is that all of the code for everything you see is embedded in the Markdown. And this is really important. This means that another city can come along, you have a similar problem, grab your code, replicate your code on their own data, and do something awesome with it. And we're already seeing this happening with other governments grabbing our students' projects and making it their own. So these markdowns, having a reproducible markdown with code that's really driven by data visualization and the public policy nuance, that's a really important contributing factor to the success of the Musa practicum. Another thing I'd mention that is important is these interactive maps. So every team builds some kind of dashboard. Here is the team for Syracuse last year that was trying to build an application that would help inspectors, building inspectors, be more efficient and effective. So they built a machine learning model that would predict the probability for a various property that it would have a building violation, and then develop this app that's super interactive to try to understand, to try to guide a building inspector on properties to inspect. It's an amazingly beautiful product that they created, again, towards the Musa practicum. And so my hope is that all of you are excited about joining the practicum. It's pretty competitive, and it is an amazing opportunity to do work that's actually applied. And our students who do the practicum get their jobs on the back of these projects. All right, moving on from the practicum. I mentioned the importance of open source in everything we do. And I just want to touch on that again. So in the 2 semesters you're with us, we will expose you to 3 programming languages, R, Python, JavaScript, and a smattering of a couple others. All open source, tremendous amounts of resources for learning these tools on the web. We use a host of data visualization, open source data visualization technologies, including Shiny, Mapbox, and Dash. And we also place a huge amount of emphasis on communication. So data visualization is just one kind of communication. We also talk about memo writing and presentations, and we use all these technologies you see here to make it possible for us to communicate, not just towards other engineers, not towards technical people, but towards non-technical, the kinds of managers you'll be working with when you enter the labor force. All right. Because we're so applied, because we're so quick, and we shove so many skills into your head so fast, the emphasis is on getting skills. And I talked about communication. Well, one of the best ways that our students communicate what they do is through their portfolios. And I want to give you an example of a portfolio right now. This is a current student. The work on her portfolio is only work that she has done in her fall semester. So none of her spring work is up here yet. But this is a beautiful portfolio. It's all on GitHub. And each one of these is a separate markdown. This was a project that she did in my class in the fall. And again, just like the practicum, the idea is that everything, all the text is really there to move the reader from data visualization to data visualization. And the whole idea of these portfolios, and this one absolutely fits the bill here, is that a potential employer can look at this portfolio and in 5 minutes be confident that this student will be able to come in to this job and make a contribution immediately. And so we put a lot of emphasis on these portfolios. They are really important. And if you're following along at the end of March, early April of 2020, you're watching this video on the Musa Twitter account last week and this week, we'll be posting portfolios for our current students. So you should go onto our Twitter page and check those out, get a sense of the kind of work that our students are doing. All right, we spent a lot of time trying to have our students interact both at the computer and not at the computer. So this picture in the middle is from a bowling alley the students participated in the fall. And we try the program tends to be fairly small, between 20 and 30 students, and Musa students are all pretty tight knit, really tight knit group. We have a number of talks and events every semester. Probably the most important ones are the Musa Masterclass, which is a really fun and engaging event. We bring in an expert who does something pretty niche somewhere in the world. They build a tutorial specifically for us, and they come to Penn and they give us this masterclass. We also broadcast the masterclass via webcast across the world. I just want to emphasize the close-knit nature of these students, and you're all taking the same classes. You're all learning at the same level, and these are the students these are the networks you will make going forth into your career going forward. Now, most of you, as I said, are coming in with some background in spatial analysis or statistics, but not all of you. And some have more experience than others, and others are looking for an opportunity to brush up. And we offer a summer boot camp that I think most of you would benefit from, and probably all of you would benefit from, and certainly most of you it would be recommended. And what this is an intro and intermediate introduction to vector and raster spatial analysis in ArcGIS, and an introduction to spatial data analysis in R. This is offered 2 weeks before the semester starts in August. But you can send me an email, we can talk more about it. But I think it's a great opportunity to start to get to know your peers, but also to dive right in. In the fall, we don't allow Musa students to take the introductory data classes that some of the city planning students will be taking. We really throw you in, and so having access to this boot camp typically is important for many students. All right, that was a tremendous amount of information, and no doubt you are saying to yourself, how is it possible? I've taken a couple GIS classes in college. How is it possible that I could learn all these skills and build out these impressive portfolio items in 1 year? And here's what I say to that, because it's an incredibly important question. First thing you should know is that the Musa program is very intense. The courses are hard. It takes a lot of time. And those, most of our students are super excited to learn these skills because they are so cutting edge. And they're willing to spend that year working really hard to learn those skills, particularly because they know that the labor market will snatch them up pretty quickly. The Musa students are the most competitive program. The Musa program is in the Weitzman School with respect to our students getting jobs the fastest and making the most money. And that's because our students are very much in demand. So while it is a very intensive program, it tends to be, students tend to enjoy the program because there is so much creativity, so much new learning, and so much problem solving. It is not really book learning. It's about solving problems and using your time, your energy, and your creativity to do that. And I urge you to talk to some current and former Musa students who will be at the live open house on April 7th. But we foster an atmosphere, I think, where despite the learning being really intense, the students tend to enjoy it. So that's it for me. Again, I'm happy to answer. I know a lot of you have a lot of questions. I will answer them on April 7th at the live open house. But I thank you for listening, and I hope to work with you all in the fall.